Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of biweekly contest 77. The question name is count unguarded cells in the grid. So I'll just explain it using a whiteboard. Uh, just a second. Yep. Yeah. So in this problem, we are given a grid. It says M cross N grid, and there are cells in that grid, and some of the cells are occupied either by a guard or a wall. So the either some guards can be present at some cells, or some walls can be present at some cells, or the remaining cells will be unoccupied. So in the indices of those guards and walls are given. So suppose if I say G, that means a guard is present at this index, a wall is present at this index, a guard is present at this index, and for example, a guard is present at this index, a wall here, and so on. So the problem gives us this information. Now, what it says is that this guard, if we consider this guard, then this guard can see into these cells. It sees in the any guard can see in four directions: up, left, down, and right. So all the four directions a guard can see, and a guard can see all the cells present in either of the directions until that guard sees an obstruction. Now, what do we mean by that? Now, this guard, if he sees in the right direction, then this cell is unoccupied, so he can see in this cell. This cell is also unoccupied, he can see in this cell. This cell is also unoccupied, he can see in this cell. But this cell is occupied. It is being obstructed by a guard. So this guard, if there would have been one more column, like for example like this, then this guard, the guard that we are considering, would have not seen in this cell because there is an obstruction present here. So these are the three cells this guard can see when he sees in the right direction. Now, if we consider the left direction, then there is only one cell present, and that is not being obstructed. So this guard can see this cell as well. If we go to the up direction, then there is no cell present because we are moving out of the grid. So again, no cell when this guard can see no cell above. However, if we move into the down direction, we can see that again this cell is not being obstructed. So we can move ahead. This cell is not being obstructed. So these two cells will be guarded by by this guard. So the term here is guarded. So these are the cells that this guard can see. If we look into another guard, then if we see this guard present in the second row, then this guard, I'll just make it a little bit clean. Just a second. Okay, this is a row, this is a row, and this is a guard. Okay, now it's good. So this guard can see here again in four directions. So this cell is unoccupied, this cell is unoccupied. So this guard can see in these two cells. So these cells will be guarded by this guard. Now again, if we talk about the left direction, so this guard can see this cell, this cell. This cell is already being seen by this guard. So again, a cell can be seen by multiple guards. That's not an issue. So again, this is being guarded, and again there is no obstruction here, so this guard can see this cell also. So all these cells are being guarded. It doesn't matter by which guard, but these cells are being guarded. Now if we just consider one more example, so if a guard is present here also, that means in the last row, so this guard can see in this direction, this guard can see in the left direction, and when he sees in the left direction, he can see this, he can guard this cell, but this cell is already being occupied by a wall, so we can't move beyond this particular cell. So this guard can only guard this cell on the left side. This guard can probably see this cell on the right side, and again on the top, this guard can see this cell, and again on the down there is no cell. So this is the main thing, that each guard can see in four directions, and he can keep on seeing until there is some obstruction by a guard or a wall. Yeah. So we need to return the number of unoccupied cells. After all this thing is done, we need to return the number of unoccupied cells uh, that are not being guarded by any guard. Okay, so that means in this example that we have seen, this this is the cell hash. I'm representing by hash. This is the cell that is not being guarded by any of the guards. I think rest of the cells are being guarded. Yeah, this guard is guarding this much, this guard is, yeah. So this is so we need to return the count of the cells that are not being occupied, I would say. So if we go to the logic, if we go to the logic of this one, then I've used a simple one. Like what we can do here is that if we consider the grid, if we consider the grid, and if we consider a particular cell, so what we can do is that this is the current position of the guard. We can keep on checking in the up direction until we find there is a guard or a wall present. So we can keep on doing this. So and we can mark all the cells as visited by representing one or something like that. We'll see that in the code. The main logic is there. Given a particular position of a guard, we can move in one of the directions and we can mark all the cells. Uh, we will keep on moving until we find either a guard or a wall in this direction. So all the cells till that particular point will be marked. Again, we'll move in the right direction. That means the row will be same, the column will be increased because the row value will be same. We are moving on the right. The column value will be increased one by one. So again, we'll keep on moving in the right direction until and unless either we find a guard or a wall. We'll do that for the left direction as well. The row value will be same, the column count will be decreased at every step. And similarly, we'll do that for the down direction. We'll keep on moving until we find either a guard or a wall. And in this case, the row count will be increasing, the column will be same. So this is the main logic that we will use, that we have used in the solution. Let's go through the code. Let's go through the code. So we have seen the example. Let's see one of the examples as well. So this is a grid represented by you can see G and W, and all the red cells are being guarded by a guard, and all the red cells are being guarded by a guard, and all the green cells are the ones that are unoccupied and that are not guarded. So the count of these cells are 7. And if we move to the second example, we can see that again there is a guard and there are 4 walls. So this guard is not able to see any of the cells, not able to guard any of the cells. So we have 4 green cells. So answer will be 4. Now, as I told you in the logic, so if I come to the main function, then I have initialized a grid of m cross n, and for every position where a guard is present, I have assigned a value to that particular index. We'll see why we have done this. And for every wall as well, we have assigned the value to. This is done because when we will start traversing the grid for every guard position, so we have to mark the cells as visited. So we have used 1 to denote that okay, this cell is visited, and we have used a different number 2 uh, to represent there is an obstruction and you can't move beyond this cell. So 1 means that cell is visited, but 2 means that okay, now stop at this place. You can't move beyond this cell. So that's the main reason. Because if a guard keeps on moving in a particular direction, and if he sees a guard or a wall, then he can't keep on moving in that direction. At that particular point, that guard will stop, as we saw in the diagram. So that's why we have we have put 2 at every position where a guard or a wall is present, and then for every guard position, we have called a function by passing the current position of the guard. I've made it DFS. Not exactly DFS, but again, initially my thought process was going towards DFS. That is why I named the function as DFS. So again, we pass the current row and the current column here, and we mark it as visited. And as discussed in the diagram, so we here we see we will be moving in a particular direction. Now this direction is moving towards top. That means the column is same, but the row count is decreasing. So we'll move until we have at least one row in the grid. So that means the value of r is greater than or equal to 0. If the value of current cell is not equal to 2, that means if it's not an obstruction, then mark that as visited and again keep moving up. However, if this is an obstruction, just break the loop because you can't move up now, right? Similarly, we move to the down direction and we keep on moving until we find an obstruction, as we can see. And similar is the case for column. So this is the case where we move left. That means the row is same, but the column is decreasing. So we keep on moving until the value is not equal to 2. That means there is no obstruction. We mark the cell as visited and we decrement the column count. And similar, we move to the right direction. So we do this thing for every position of the guard, we can see here. And at last, what we are doing is that we are traversing the grid, and we are seeing how many grids have value 0. That will represent that, okay, these cells were not visited. These are, sorry, these are not occupied by any of the guards. So yeah, this gives us the answer. And yeah, again, I would say an implementation based question. Uh, but yeah, enjoyed it. So if you learned something new from this video, then do support it by giving a like and also subscribing to the channel. Thanks a lot for your time. Bye bye.